how's it going? Okay, I just wanted to talk about our calendar really quickly. So we are here today. So we finished that yesterday. So looking ahead, today and tomorrow we're going to talk about the experiment. And it's got a lot of stuff and a lot of vocab. So I really want to make sure you understand it. And then Thursday is your quiz. Just a reminder, it's over modules 4 through 6. And then after we take that quiz, we'll finish up the whole unit. And then Friday, gosh, I hope I'm back by then. We are meeting in Excel to hand back your quizzes. And then your summaries are due that day. Sound good? Okay, so let me just talk about the quiz. So just a reminder, there's 20 questions. 10 of them are multiple choice, and the other 10 are definitions. So just straight up, write your definitions out. Where are those words coming from? They're coming from your summaries. So guys, this is one of those things where I was talking to do a little bit every night. You can't wait until this night here and then you're just cramming everything. So all those definitions, all the vocab words, I think there's 15 in the summaries. Those are on the quiz. Thank you. So you'll get 10 of them and you'll have to write the definition. So I would definitely practice somehow. Maybe it's talking to a friend, maybe it's you writing it out, but whatever it is, definitely practice before that. And so what do you study for this? And basically, it could be anything in modules 4 through 6. Each module, I think, has practice questions that might help. I know there's plenty of online questions. Oh, this worksheet. All right, this is a great tool for the quiz. So knowing what each one is, pros and cons, and then these vocab words on the right. Okay? And then today we'll do the experiment. You're going to get a new worksheet for that in a little bit. Okay, so that's gone. We don't need that one. Okay, what I want you to get out is the worksheet that you did. This one. So I'm going to go ahead and start. So pause me if you need a second to get it out. So just a reminder, right? Correlations show if things are related or not. I'm going to start with this sheet while you're getting that out. Okay, you don't have the sheet, so don't worry about it. But, right, we can find out in psychology, actually, and just in science too, are happiness and what would you say, chocolate related? Is there a correlation between how much chocolate you eat? Or is it, one thing we talk about is money related to happiness? Are those correlated? Cleanliness and what other variable would you put there? Maybe it's organized, organization habits. Maybe what do you think? GPA? Will those be related? I don't know. Aggression. Okay, you get the point here. So a correlation, right, is a number that's showing if two things are related. And then you're going to get, basically, they take all these things. This is actually important. I know I asked this later, but how do you get these things? So, like, for example, if you want to know how COVID vaccines are related to infection, then you would get all that data. Right now, that data comes from, I guess you could say, the CDC or whatever, hospitals. And then you basically put all that data into the computer, and that would come up with a number. And it would say if those two variables are related. You could do it, I mean, really with any two variables. But another way you get it is, like, let's say you want to do brushing teeth and Crest use or toothbrush use or something like that, a certain kind of toothpaste. That might not be in the CDC, right? So you could get your data from that from a survey, right? You send out surveys to everybody or as many people as you want. Ideally, it's a big number, and then you come back and it's what am I trying to say? And you come back and it is, you find out, right? That you put all those numbers into the computer or the calculator and they decide, they give you this correlational coefficient. Okay, I'm gonna actually come down here real quick. Remember, a correlation coefficient, it can only go from -1 to 1. It cannot go past that. So this is a missed question so many times. People will say they'll pick something that's like 1.2 correlation coefficient. Nah, that's not a thing. That does not exist. Remember, the stronger it is to -1 or the stronger it is to 1, that means it is a strong relationship. And then the negative versus the positive, what does that mean? And that goes to this up here. Okay. I know this is a repeat, but I'm just going to repeat for you real quick. If two things go up together, so studying and GPA, those both go up, right? The more you study, the higher your GPA. That is a positive correlation. So I would say positive correlation, right? If they both go up, that means they both go down together too, right? That means the less you study, the lower your GPA, right? That's a negative. Sorry, that is still a positive correlation, right? But they both go down to each other. They both go up. So if this comes up, oh goodness gracious, okay, then that is also a positive correlation. Okay, well, positive correlation as well. Now here's where you get a negative correlation. One goes up, one goes down. The more you brush your teeth, right? The more you brush your teeth, the less cavities you have. One goes up, one goes down. That is a negative. All right, so let's see on your worksheet if you got this right. These are negative, positive, or no correlation. All right, number of hours of TV watched. So I don't have a little pin, but I literally would draw on here. The more TV you watch, what happens to your GPA? It probably goes down. So that's a negative correlation. Wealth and happiness is an interesting one. This is kind of like what you think here. The more money you have, does your happiness go up? Kind of the studies say that it goes up to a certain point. So it's not going to be a super, super, super strong correlation, but they are related. So that would be a positive correlation. Age of car. How old is your car? How well can it brake? How well can it stop? The older your car is, the ability to brake goes down. Right? That makes sense? That's a negative relationship. Caffeine consumption and hours of sleep. The more caffeine you drink, the less hours of sleep. Those are negatively related. I know I'm going slow here. I'm going to go faster in a second. But height and weight, the taller you are, the more you weigh to a certain point. So that's a positive correlation. Okay, study time, errors on exam. The more time you study, the less errors. Negative. SAT, circumference of right big toe. 0. That is not a relationship there. Reading for pleasure and GPA. Positive. You could say less reading for pleasure, lower GPA. Hair color intelligence. That's a 0. Test performance and anxiety. That's negative. Teletubbies, watching as children, adult psychosis. That's a 0. Foot size and age, to a certain point, it's positive. All right, you get the point. I'm going to stop going through these. But that is something you got to know, okay? Now, just kind of going back to this. Oh, do I want to save my changes? Sure. I don't know what changes I made. You know if it's positive or negative. That's good. Well, now, like I told you, it can only go from -1 to 1. So let's look at, and anytime you see this R, that stands for what is the correlation, right? What is the relationship between two variables? So let's say that I did a study on, okay, positive correlation, but I'm looking at this one right here. Both of these are positive, right? There's no negative sign between either one of them. So what's a positive correlation? What did we just say? The more you study, the higher your GPA. Which one is, so if I took all this survey and I found out how long people study and I found out what their GPA is and I stuck it into this calculator and came up with this coefficient here, I have either 0.2 or 0.76. Which one is a stronger correlation? Okay, good job. That was an easy one. So that means 0.76 is right here on that line. That is a very strong correlation. 1 is perfect. We don't get 1. One just rarely happens for things to be that related. It's not real life. Actually, in psychology, most things, if it's a good, it's like a 0.4, 0.5. But here, we're just hypothetical. This one's better, right? Okay, what about here? Which one is stronger? Negative 0.5 or negative 0.32? This one, negative 0.5, right? That is bigger number. So it's here versus here. Remember, anything close to 0 is not good. It's a very weak correlation. Okay? This one, negative 0.7 versus 0.65, which one is stronger? Negative 0.7 is stronger. It's closer to a 1. The negative does not mean it's a bad thing or anything. That means that one goes up, one goes down. So I could say that the more you brush your teeth, the less cavities. There's a negative 0.7 correlation. That's a good correlation. That means we know brushing your teeth is related to cavities. So negative 0.7 is a stronger correlation than 0.65. Okay, negative 1 to 0.9. Negative 1's closer. You get the gist here? Well, how about this last one? 1, negative 1, which one's stronger? They're both the same. All right? And then up here, 0.05 versus 0.5. 0.05 is very close to 0, right? That means there's no relationship. What did that one say? The relationship with your big toe and your SAT, right? Something like that. Okay. And I showed you the scatter plot of things on the right, what those look like. If there's a positive correlation versus a negative correlation. Okay, we already saw that. This was on an old free response a couple years ago, but the main thing I want you to know, and we've already talked about this, right? Just because things are correlated, just because they're related to each other, does not mean that they cause each other. Why? Because there's so many different things out there that could. So, for example, ready? If we did marriage and gray hair, right? The longer you're married, the more gray hair you have. And so you do a survey of some sort about how long have you been married, how much gray hair do you have. It's going to be very, very, very correlated, those two things, because they both deal with age. But just because they're related does not mean that this causes this. All we know in this is that they're related. Okay, the only way we can find out if something causes something else is an experiment. And that's what we're going to today. Sound good? Okay. Dun, dun, dun. All right, so take out this worksheet. Just I'll give you a heads up. Sorry, I'm thinking. We may not get to everything here, and you'll watch the rest tomorrow or something like that. So just so you know. Okay, I'm gonna try and do something crazy here. Let's see if it works. It may not. You know what? Let's just read this experiment. Sorry, I'm thinking. Okay, it's just different if I do it in person here. Okay, just have this worksheet. We'll just pull it back out in a second. Okay, so an experiment. Dun, dun, dun. I think I just made that sound a second ago. So experiment. This is so important. It's the only thing out of all those studies we did, naturalistic observation, survey, case study, correlation. This is the only one that we can find out if this causes this. And why? Because I can manipulate everything I want to manipulate in an experiment where I know that this group compared to this placebo group, that it's exactly the same except for one thing that I choose and that I'm studying. So everything is the exact same. Okay? Okay. I am going to start out with real quick because you already know it. We already talked about this, so that's why I was going to bring it up real quick. All right, if I want to do an experiment, right, and I want to study private schools across the United States, that'd be a lot, but okay. Or I can do private schools in the South or in Georgia. That sounds easier. Okay, so the population, right? I'm going to write this down here, is the entire group you want to study. The entire group you're interested in studying. Do you actually get to? No, because we don't have time to study every single person in all the private schools, or maybe even every single private school. Okay, so sample is the actual group you end up studying. Academic wording, but that's okay. And what I'm going to write on here, because I know we already did this, it has to be representative of the population. How do you do that? I know this is, sorry, repeating myself. How do you do that? The sample must be random. All right, so let's talk about that real quick. I know I've already done it. I want to study, let's just make it easy. I want to study Heritage Upper School students. Okay. That's my population. I don't have time or money or whatever to study all of Heritage Upper School, but my population is the Heritage Upper School students. Sample is let's do 50. I want to do 50 people. Don't want to do something too small. If you only study 5 people, is that really going to be representative of the whole population? It's not, right? So you want, the bigger amount of people you can get is the better, right? Because that means you're just getting more and more of a chance to get that whole population. Okay, and how do you do that? You have to make sure that it's random. So you do not want the first 20 people at school or first 50 people at school. Why? Is there something different about the first 50 people than the second 50? Yeah, and it could be they are more time conscientious, which means they're more organized, which means maybe their GPA, I don't know. I'm just making stuff up. But there is something different about think about the last like 10 people to school every day, right? I'm not saying either one is better. I'm just saying you need to make sure that you have people from all different types to represent that population. All right? Okay. So now that you've got your sample of like 50 people, all right, now you want to figure out what are you studying. Okay, what do you really want to know here? Well, let's say I want to do a study on if this pill that I just made affects happiness levels. Okay, I want to know if this pill affects happiness levels. I know you guys did this at some point back in another class. I don't know what grade. Independent variables, dependent. It sounds like a science, biology. I don't know. Okay, independent variable. So some of you can get tricked up on this, and so I would encourage you to take practice questions to help you if you keep getting stuck. Independent variable is the variable that the researcher changes, one that they manipulate. The variable that is manipulated by the experimenter. I'm going to write that down. Okay, so in my little study, I want to see if a pill, right, affects happiness level. So what am I manipulating? I'm going to have different groups, right? I'm going to see if they will take this pill, right, and if it affects their happiness level. So the independent variable is in this experiment would be my pill, right? I want to see if this pill affects things. What is it affecting? The dependent variable, the variable that is responding to the independent variable. So here, if you get a happiness pill, if you get a pill, is it affecting your happiness? So will your happiness go up, down, right? That is really what I'm looking for. That's what I'm looking for. I'm measuring that. Experimenter. Um, experiment or by the independent variable. Variable they are measuring. Okay. All right. Got my pill, and I'm looking for happiness. Right? Does it change happiness? Well, I need to know. Let's say I give the pill to all 50 people. Okay, and I see some changes. But I'm like, would this have happened to everybody, right? With this little pill? Do they think this pill is going to make them better? You need to have two groups. You need the experimental group. This is the group that receives the treatment. So whatever, like here, they are receiving this happiness pill. Boom, you got it. All right, and I want to study how it affects our happiness. Control group is the group that does not receive the treatment. And here, they would actually receive a placebo. Okay, but here, real quick, it's used to compare against the experimental group. One group gets it and one group doesn't. Or in this situation I'm talking about, one group gets it and one gets a placebo, like a fake pill that we're going to talk about right now. Group that gets the treatment, the group that receives the treatment, and this is the group that receives no treatment. So like for example, with the vaccines, when they were doing studies on the vaccines, I know I keep talking about that. It's just what's kind of modern right now. When they were trying to decide if these were effective, half of the people that were in these studies got placebos, which are dun, 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 placebo is basically a fake pill, a sugar pill, essentially. So they get something that really just has sugar in it, or a slight amount. And because here's the reason why do they do that? Because some people, if they think they're getting a pill, right, they might act differently. Like, oh, here you go, I got the memory pill, right? But if they don't know which one they're getting, if it's placebo or whatever, then they can't really. That's that bias we talked about, that subject bias. So yeah, a placebo effect when a patient believes, right, that it will work. My perfect example is giving a band-aid to a little kid who hasn't really gotten hurt. We're like, here's a band-aid. That'll fix you. And they're like, so that's a placebo effect. Okay. When patients believe that a placebo why if you're using some kind of pill here, you have. Okay. All right. Next. Now, if I am okay, so if I'm the experimenter and I'm in charge of it, right? And I know that this pill is the real deal and this pill over here is the placebo, I might, without even kind of realizing, I might give it the real pill to somebody and be like, hey, welcome, right? Now, hopefully that would not actually happen, but it would be a little bit like more like you didn't realize, but you acted in a way that might influence them to think they got it versus the placebo. You're like, here you go. Good luck. Whatever. So how do they get rid of that potential bias, right? So they do this thing called a double blind. It's kind of like this picture here, where they make sure that neither the recipient nor the experimenter knows what they're giving and what they're getting. Now, how in the world? Somebody's got to know. So there is somebody behind the scenes, right, that knows which pill is which. The red pill is this, the blue pill is that. And they set it out, right, in front or on a, I don't know, counter. And then they kind of walk away and the guy picks it up. So they don't know which one they're getting. So yeah, when neither the experimenter nor the participants know which treatment is given, and that's again to eliminate unintentional, like, oops, good luck, you got the real deal. Okay, cool. So that's called a double blind because both people here are it's out of order a little bit. When neither the experimenter or the participant knows which condition they're in, which group they're in. What did I say? All right, let's keep it going. I know this is a lot of vocab words here. So you just have to make sure that, as you're going through this list, that does it make sense to you, right? Keep repeating it to yourself. Don't just memorize the, what's on that worksheet. Understand it. Okay, so you remember what random sampling, we just talked about this, right? So you have 100, I don't know, how many people do we have at Heritage? I don't know. You have your whole population in your upper school, right? That's your whole population. And you want to get a random sample. What's the best way to do it? We talked about the wrong way to do it. Don't get the first 20 people, first 50 people. You want to have a way where you have all the names in a hat and you pull out 50. So what's probably a better way to do this? Put it in a computer, all the names, and the computer auto generates, random names. And that just totally gives every single person in that population equal chance of getting picked, right? Because you want that sample to represent your whole population. Okay? So there you go. A sample that fairly represents a population because each member has an equal chance of inclusion. Okay? Random. If you're in stats, you actually might do this. Did you know that there's like a percentage that of M&Ms, like they know kind of on average how many browns are in, how many blues are in, how many yellows are in. It's not equal. What? It's probably some psychology behind that of which colors are more representative. If you pour all these M&Ms from certain bags right in there, and let's say that they put in there 30% blues, right? And you mix them all up, and you grab 10. Ideally, that sample's not very big, but ideally you would get how many? 30%. So 3 blue M&Ms if you grab 10, right? So that sample would represent your whole population there. Okay, so that's how I get my sample. All right, I get my 50 students from Heritage. And then what I do is I have my 2 groups, my experimental group and my control group. I need to put them into these 2 groups, right? So I need 25 in both. So what happens, the same kind of random number generator or whatever, pick out of a hat, but it has to be random, and you randomly assign 25 to one group and 25 to the other group. And this is just for experiments. Random sampling can be used for surveys, but here you don't have experimental groups in surveys. So here we go. So assigning participants to both of those by chance. Because again, it's totally random. This group will be pretty similar to this group. Okay, so you'll probably have the same, well, I was gonna say the same amount of boys. Yes, roughly the same amount of boys in each, roughly the same amount of girls in each, if it's done by chance. And you'll have roughly the same amount of morning people, in both groups. So you want these two groups to be as similar as possible. Some high GPA, some high GPA, some low GPA, some low GPA. You want that kind of equal, because then this group represents all of the upper school, and this group represents all of the upper school. Okay? If you had all girls here and all boys here, the experiment wouldn't work, right? Because you could say, oh, the pill worked. Well, did it work, or did it just work on here on guys and it didn't work for girls, or something like that? Okay. All right, sound good? Minimizes pre-existing differences. So yeah, I just saying, like, you want the groups to be very similar. Okay, how are we doing on this sheet? Okay, so randomly assigns participants. Why? So that they are similar to similar groups. They are both, I don't want to type all this. Both. All boys and all girls. Okay. So let's say I do my study, and what I find out is that my pill works. Okay, the people that get the treatment, it works because what I end up finding is that their moods, their happiness has greatly increased. We're going to talk about how we measure that in a little bit, because that's important. But I found that their happiness increases, and the other group, the control, just pretty much stayed the same. So yay, my pill should go to market now. Put it in Kroger. Go on. Get the FDA to improve it, to approve it. Speaking, whatever. Okay. I was going to say, like, what happens in order for any drug to ultimately get approved by the FDA? It's not going to take one, scientist doing one experiment and saying, boom, that's it. It has to be replicated. And the results have to be similar in all these replications. So replication, you have to repeat the study, and the results have to be very similar. I have to repeat it, and then all my colleagues, all of them, lots of colleagues have to repeat it so many times. And that makes sense, right? You obviously don't want to take a drug unless it's been repeated and you know that it works. Okay, well, in order for Joe over here to repeat my experiment, he needs to know exactly how I did everything, right? He needs to know every single detail so he can replicate it, right? So he needs to know exactly what my independent variable is, that pill. He needs to know how many milligrams it is and what color it is, and he needs to know what time of day the pill was given. He needs to know, did a male give it? Did a female give it? Was it whatever? Okay. He needs to know all that. And okay, he needs to know the dependent variable too. Think about this. I just said happiness. Well, what if he thinks happiness is a mood ring? Okay, and he makes all of his participants wear mood rings and nothing happened, nothing changed. He needs to know what I did, and what I would say I would do is do some kind of survey or something, talk about about their mood. You could do that. You could have them chart how many times a day they laugh. I don't know. Whatever it is here. Serotonin levels in their body. Okay. But whatever it is, I have to exactly define what my independent, what my dependent variables were, so somebody can replicate it. Okay, there we go. So this is the one that people get lost on sometimes. This word says operational definitions, and it's what I just said. A statement of the procedures used to define research variables. That's a fancy way of saying, how did you measure your independent variable? How did you measure your dependent variable? So I'm going to measure how a pill affects memory. Okay, well, how am I going to measure memory? How do I define that? Operational definition. How do I define that so that Joe can repeat it and get exact same results? So maybe I would say it scores on a memory test. They take it before taking the pill, they take it after taking the pill, and then was there improvement, right? But I need to know exactly what that memory test was. Okay, why do you need to define it so you can replicate it? Okay, let me go to my sheet. Repeated with similar results. Operational definition. Okay. When variables are, there's fancier definitions in the book. Okay, I'm going kind of real quick off my mind here. When variables are specifically described, so I would say variables in an experience. So it okay. So we're gonna dig into this word here a lot more kind of later on in a different chapter. But now that I did my whole experiment, did that test actually measure what it's supposed to measure? Was this experiment, did it measure what it's supposed to measure? Okay, oops, there we go. So, is it valid? You've heard that before. Does the test measure what is intended to measure? So, kind of my example here is that memory test that I gave them. We were just talking about that memory test, right? The pill, improve the memory. Does that actually measure memory, right? Or was that random test just measuring their calculus ability? So you just have to make sure that if you give something, it measures what it's supposed to measure. So at the end of this year, if you take an AP test, are there questions about psychology, or are there questions about AP US history on there? All right, 2 more, right? And then we'll stop. A confounding variable. All right, so let's say we do an experiment. I did my let's do my happiness. Okay, you get this pill, you don't. You get this pill, you don't. You get this pill. Okay, and I find out that this group, their happiness scores went up because they got the pill, and this group it didn't. But what I didn't realize is that the pill group took their happiness test at 10 o'clock in the morning. This group took their happiness test at what's a grumpy time? 6 in the morning, 2 o'clock in the afternoon, whatever it is. They took it at different times. Could that affect happiness? Yes, I'm not super chipper at 6 a.m. What about if this one, the happiness test, was given by an angry old woman? Okay, and then this test was given by a 21-year-old whatever. Okay, could that affect it? Yes, right? That could affect happiness. You see, I can keep going here. Here's another one. The happiness or the group that got the pill, they took it in a really bright room. This group over here took it in a really dark room, their happiness test. That would affect your mood. Okay, so you can pick any nine of these things. If there's one thing in your experiment that is not exactly the same, it messes you up, right? It messes up the results. So here's a fancy way of saying that. When a variable, other than the independent variable, affects the outcome of the experiment. So remember, the only thing that's supposed to be different is that one independent variable. It's just the pill. The time shouldn't be different, but the temperature of the room, oh, that's a good one. I would not be happy if it was like super cold, and Mr. Marchman would not be happy if it was super hot. So you need to make sure that that variable is just the only thing that's different there. So confounding variable, also known as like confusing variable, messes everything up. Does a test measure what it is supposed to measure? Pause me if I'm going too fast here. Confounding variable when variable other than the independent variable messes up the experimental results. Okay, here's the last one. So how do I know I talked about correlation does not prove causation, right? Just because they're correlated. Or let's say you did a naturalistic observation and you found out that, I don't know. Okay, sorry. You found out that you think that heritage people are happy by watching them. You cannot say that this causes that, right? Who knows? Heritage could have gotten popsicles that day, and that's why they're happy. You can't say cause and effect with anything other than an experiment. So I'm going to say this. Only experiment prove cause and effect. Why? This is the important part. Why? Because they make sure that everything in these two groups, everything in their experiment is controlled, is the same except for the independent variable. Except the independent. All right. Boom, we did it. Any questions? Nope, great. All right. That's it. Good job.